Okay, good afternoon. Our objective for today is to be able to write and solve proportions. Now, by 8th grade, I always tell my students, you should be able to, solve proportions by now. You've been doing these since 6th grade. However, the tricky part comes with writing the proportions because often students will confuse the numerator and the denominator when they're writing a proportion, and then therefore, their solution to, any proportional word problem is going to be incorrect. All right, so let's get started. First vocabulary word for today is a proportion. What is it? It's an equation stating that two ratios are equal. For example, if we have a ratio of 1 to 2, that is the same as the ratio 5 to 10. 1 out of 2 is the same as 5 out of 10. Those two equal ratios form a proportion. Second vocabulary term, cross products. What are they? Cross products are found by multiplying the denominator of one ratio by the numerator of another. All right, let's get to some examples. We can use cross products to determine if two ratios form a proportion. Let's try it. When I check the cross products here, I multiply 18 times 15. It's going to give me 270. I multiply 27 times 10. It's also going to give me a product of 270. My cross products are equal. 270 equals 270. That means then that these two ratios are equal. Because the two ratios are equal, they form a proportion. All right. Now, what else you can do to determine if the two ratios form a proportion, you could also simplify the ratio. How do you do it? Well, if you simplify the ratio to simplest form, 10 over 18, simplest form, 5 out of 9. 15 out of 27, simplest form, 5 out of 9. You can see that the simplest form of each of these ratios are the same, and if the simplest form is the same, they're proportional. Alright, let's take a look at our next example. 12 times 12, if I check the cross product, 12 times 12 is 144. I check the cross products here, 9 times 15, 135. 135 does not equal 144. That means then that the ratio of 9 to 12 is not the same as the ratio 12 to 15. We can confirm that by checking the simplest form of each of those ratios. 9 out of 12 in simplest form is 3 out of 4. Simplest form of 12 out of 15 is 4 out of 5. Once again, you can see that the simplest form of the ratios are not equal, therefore the ratios are not proportional. Our next example, let's check the cross products. We have 5 6 and 15 eighteenths. 6 times 15, 90. 5 times 18, 90. Cross products are equal, ratios are proportional. Next example, 27 times 2, 54. 6 times 9, 54. Cross products are equal, ratios are proportional. Alright, the next two examples you could do on your own. I would just ask you to check to see if the cross products are the same. If the cross products are the same, the ratios are proportional. Let's move on to our next next part of our objective. We want to be able to solve proportions. And when we solve proportions, we want to find the cross products, and then we want to use division. Okay, our first example. We have some number out of 5 is going to be the same as 6 out of 15. I want to know what out of 5 is the same as 15, 6 out of 15. So first I find the cross product. 5 times 6 is 30. My other cross product, 15 times c, I write this 15c. Cross products are equal. Once again, we set the cross products equal to each other. When you do that, you have a one-step equation with multiplication. 15 times a number is equal to 30. I want to solve that one-step equation using the opposite operation, which is division. So I will divide both sides of that equation by 15. 15's cancel, and I'm left with c is equal to 2. So we're saying that 2 out of 5 is the same as 6 out of 15. All right, let's try the next example. Cross products, 12 times z, 12z, 7 times 51, 357. I use division to solve for z. When I divide both sides of the equation by z, z is going to be equal to 29.75. Next example, 6 times 8, 48, 12 times x, 12x. I set the cross products equal to each other. I use division to solve for x. Divide both sides by 12. X is going to be equal to 4. We're saying that 4 out of 6 is the same as 8 out of 12. All right, the last two examples I think you could do on your own. Just find the cross products first, then use division, and you should be able to find the solutions to the next two examples. All right, now, the most important part of our objective, being able to write proportions for the word problems. All right, let's begin. In each one of these word problems, you're going to be given a ratio contained within a sentence. And I see that this sentence here says that the ratio of red to yellow is 3 to 5. Whatever ratio you're given, you write as a fraction. The ratio of red to yellow is 3 to 5, so I write the ratio 3 to 5. Now, 3 represents what? Red to yellow, so 3 represents the red, 5 represents the yellow. So my equal ratio has to represent that same situation, with red in the numerator, yellow in the denominator. My next sentence says, how much red paint should be mixed with 20 ounces of yellow? Well, because we're looking for red paint is in our numerator, that's going to be our variable, and 20 ounces is going to be in the denominator because that's our yellow paint. Just like we've done with those last examples, when you cross multiply and divide, all right, now you're ignoring the y and the r. 5 times n is going to give you 5n. 3 times 20 is going to be 60. And when you divide both sides by 5, it is going to be equal to 12. So we have 12 ounces there. All right, we continue our examples. We're given a ratio here. A lawnmower factory can produce 12 lawnmowers in 8 hours. So I write that ratio, 12 over 8. That's going to be equal to 12 representing lawnmowers, 8 representing hours. I'm given 30 lawnmowers. I'm asked how many hours, so I have to make sure I write a ratio that has the corresponding numerators representing lawnmowers, corresponding denominators representing hours. When you cross, multiply, and divide, we wind up with n is going to be equal to 20. 20 hours it would take to produce those lawnmowers. Next problem. 10 pounds on Earth, 4 pounds on Mars. So I write that ratio, 10 to 4. 10 representing Earth weight, 4 representing Mars weight. We're given 95 pounds on Earth. We're looking for a Mars rate. So once again, the corresponding numerators have to be the same. The numerators have to correspond. Earth weight, Mars weight, Mars weight. The denominators represent the Mars weight. Cross multiply and divide, and you'd have your answer there. Next example, we're given a ratio of 4 to 3. 4 representing orange juice, 3 representing pineapple juice. I'm given 64 ounces of orange juice. We're looking for the pineapple juice. When we cross multiply and divide, we're going to get 48 ounces. Next problem, 60 cookies, 4 cups of flour. So I write the ratio of 60 over 4. That's going to be equal to 90 cookies. We're asked how many cups of flour would we need. When we cross multiply and divide, going to wind up with 6 cups of flour. Next example. Jose read 7 pages of his book in 5 minutes. So I write the ratio, 7 to 5. 7 representing pages, 5 representing minutes. If you have 175 pages, how long is that going to take to read? We cross multiply and divide. We're going to be able to find our answer there. Problem 7. Heart beats 12 times every 5 seconds. So I write that ratio, 12 to 5. Question asks, how many times was it beating in a minute? 60 seconds. Well, if it's 12 times every 5 seconds, how many times would it be in 60 seconds? The number of beats is in the numerator, the number of seconds in the denominator. Alright, we have 3 more to do. 1,200 calories and 8 ounces of hot fudge, so that's the ratio I write. 1,200 calories in 8 ounces of fudge. The next question says, how many calories would there be in 3 ounces of fudge? We cross multiply and divide. We're going to be able to find the number of calories. Number 9, a certain college, the ratio of men to women, 6 to 5. So I write that ratio. 6 representing men, 5 representing women. If there are 1,500 men being represented in my numerator, N would have to go in my denominator, representing the women. Cross multiply and divide. You find your answer. Finally, we have problem number 10. It's a rectangle with a height to length ratio of 2 to 25. 2 to 25. That is a height to length ratio. Height in the numerator, length in the denominator. If the window is 24 feet high, 24 is your height, how long is it? That's going to be in the denominator. Cross multiply and divide, you're going to find your answer. The key when you're writing ratios for word problems is to pay attention to the numerator and the denominator of your first ratio. As long as your numerator and the denominator of the second ratio correspond to the numerator and the denominator of your first ratio, you should never have a problem. All right, I hope that's been helpful.